Hi everyone, and today we are going to continue the lecture here, that is on basics of vectors. Today we are going to continue the lecture on basics of vectors. So this is lecture number 2 on basics of vectors. So in the previous lecture we have seen what is a scalar quantity, what is a vector quantity, and how to perform the vector addition graphically and analytically. So all these things we have seen in the previous session, isn't it? So in this lecture we are going to see how to find out the component of one vector along the other, that is how to determine the scalar component and vector component of that means what I am saying here is here in this lecture we are going to see how to determine the scalar component of one vector along the other, and also how to determine the vector component of one vector along the other. Okay, so those things we will see. So after that we will see vector multiplication. So we are having two types of vector multiplications, so that is dot product and cross product. So we will see their physical interpretations and all those things, right? Okay. So next is we will see in this lecture how to determine the component of one vector, along the other, right? So this is what we are going to see in this lecture, right? So now see here. Now let us consider here I am considering some reference point, right? So from this reference point I am drawing two axes here, which are perpendicular to one another. So here I am drawing one axis and here I am drawing another axis like this, right? So let us say this is horizontal axis and let us say this is vertical axis. So horizontal axis I have represented with H, vertical axis I have represented with V, right? Okay. So whenever I have drawn this horizontal axis and vertical axis, so I can call this plane as what? As VH plane. Okay. See, so this horizontal axis and this vertical axis are called as what? V and H axis are nothing but what? Our reference axis. So what is the purpose of this reference axis here? See, whenever we draw two orthogonal coordinates like this, okay, this is going to form a plane, right? And here the reference axis are nothing but V axis and H axis. So if you want to draw the vector, you can draw any vector here in this plane. Okay, so any vector in this plane we can represent in terms of what? In terms of this reference axis. Okay, so any vector in this plane we can represent in terms of what? In terms of our reference axis. So that is the purpose of reference axis here, right? Okay. See here, if suppose I am having a vector along our reference axis, let us assume. So let us assume I am considering a vector along what? Along the horizontal axis, right? Okay, so let us say the distance from here to here, is A units, right? And this vector is pointing along which direction here? This vector is pointing along horizontal direction. So that means always, what I have told, always the direction is represented by the unit vector. So just write down the unit vector along horizontal axis, that is I am representing with AH cap. So A into AH cap will represent what? Will represent the vector along horizontal axis. Understood? Okay, so it is very easy for us to represent the vector that is pointing along what? That is pointing along our reference axis. Now similarly, if I consider a vector along vertical axis here, I am considering a vector along vertical axis. right? So let us say the distance from here to here is nothing but what? Is nothing but b units. And this vector is pointing in which direction here? It is pointing in vertical direction. So what is the unit vector along vertical direction? That is nothing but what? AV cap, AV cap, right? Okay. So here, whenever the vector is pointing along vertical direction, you can easily represent it as what? You can easily represent it as simply B into AV cap. If it is pointing along horizontal direction, we can represent it as what? A into AH cap. Understood? Okay. So this is how we can easily represent. We can easily represent a vector that is pointing along our reference axis. Right. Now we will see another case here. We will see another case. So now let us consider a vector. Let us consider a vector like this. Right. So let us consider a vector C bar. So let us assume this is C bar. So now this C bar is neither along our reference axis. It is neither along horizontal axis nor along vertical axis. Okay. So in this case, how we can represent this vector C bar? Okay. So just now I have told whatever the vector that is present in this plane, that we can represent in terms of what? In terms of the reference axis. Understood? So now here let us assume this angle here. Let us assume this angle as theta. Let us assume this angle as theta. Right. Okay. So now if you observe here, this C bar is neither along horizontal axis nor along vertical axis. So you can resolve this C bar into two components. One is along horizontal axis, another one is along vertical axis. So how to one is along horizontal axis and another one is along vertical axis. Okay. So now you have to find out the component of C bar along horizontal axis here. So how to find out the component of C bar along horizontal axis here? How to find out? What you have to do? Just drop your normal from the head of C bar onto what? Onto horizontal axis. Understood? Then the distance from here to here will give you what? Will give you the component of C bar along horizontal axis. So here in this case, the component of C bar along horizontal axis is nothing but A into AH cap. Understood? Okay. Okay. Next, if you want the component of C bar along vertical axis, what you have to do? Just drop your normal from the head of what? From the head of C bar onto what? Onto vertical axis. Understood? So the distance from here to here is nothing but what? B units. So B is the component of C bar along what? Along vertical axis. Understood? Okay. Okay. So now this C bar is having its horizontal component is AH cap, and it is having its vertical component, that is B into AV cap. Understood? So here we can represent this C bar. In terms of what? In terms of its horizontal component and vertical component. So that is C bar is equal to, I can write it as what? A into AH cap plus B into what? Plus B into AV cap. So in this manner we can represent any vector in this VH plane in terms of what? In terms of this reference axis, that is along in terms of reference axis. So that is in terms of AH cap and what? And AV cap. Right. Okay. So in another way we can write the same thing in another way in terms of theta here. See here, from this right angle triangle, this is nothing but a right angle triangle and this is the adjacent side. So this distance I can write it as what? I can write it as C cos theta. Yes or no? This hypotenuse side is C. So the distance from here to here will become what? C cos theta. And this angle will become what? This angle will become 90 minus theta. So this distance in terms of C, I can write it as what? C into what? C into cos of 90 minus theta. Yes or no? Okay. So C into cos of 90 minus theta is nothing but what? Is nothing but C sin theta. And this C cos theta is the component of C bar along horizontal direction. This C sin theta is the component of C bar along vertical direction. So I can write the C bar in this manner. So that is C bar is equal to, I can write it as what? C into cos theta. It is along which direction? Horizontal direction. So that is AH cap plus C into what? Plus C into sin theta. It is along which direction here? Vertical direction. AV cap. So in this manner we can represent the C bar. Understood? So here this is c cos theta, this is c cos theta is nothing but what? Is nothing but A, and this is c sin theta is nothing but what? Is nothing but B, is nothing but B. Okay, so in this manner we can represent the vector in terms of what? In terms of its reference axis, right? So if you observe here, if you consider only this vector here, A bar, okay, so A bar is pointing along horizontal direction, so it is having only what? It is having only horizontal component, right? And here B bar, so this is B bar here, this is B bar, and this is nothing but A bar. So this B bar is pointing along vertical direction, so it is having only one component. Understood? And here C bar is neither along horizontal nor along vertical axis, and hence it is going to have its components along horizontal axis as well as what? Vertical axis. Understood? Okay, okay. Yeah. So which means if suppose if I consider 3 coordinate axis here, let us assume I have considered 3 coordinate axis. Okay, so let us say this is x axis and y axis, and this is z axis. So I have considered 3 coordinate axis here, 3 reference axis I have considered, right? Now in this case, if suppose this is origin, and if I consider a vector r bar, I am considering a vector r bar, and this point is nothing but, let us say, x comma y comma z. Understood? Okay, so I have considered a vector. So this vector r bar is neither along x nor along y nor along z. This vector r bar is lying like this here. Understood? So I cannot draw the vector like this in air, so just assume this vector is present like this. Understood? So this vector r bar is neither along x axis nor along y axis nor along z axis. Okay, so whenever the vector is neither along our reference axis, then that vector is going to have its components along those reference axis. Yes or no? Here C bar is neither along our reference axis, and hence it is having its components along this reference axis. Similarly, if you consider 3 reference axes, and if the vector is neither along our reference axis, then that vector is going to have its components along those reference axis. Understood? Now here r bar, I can write it as what? R bar I can write it as this is origin 0, 0, 0. So it is pointing from origin to this point x comma y comma z. So as you move from this point to this point, what is the increment in x here? Increment in x is nothing but x minus 0. So x minus 0 into ax cap. What is the increment in y? So that is y minus 0 ay cap. What is the increment in z? Z minus 0 az cap. So here I can represent this r bar as what? X ax cap plus what? Plus y ay cap plus what? Z az cap. So here x represents what? X represents the x component of r bar. Yes or no? Y represents the y component of r bar, and z represents the z component of r bar. So since r bar is neither along x nor along y nor along z, it is going to have its components along those reference axes. Okay, if r bar is lying only in xy plane here, then it is going to have only x and y components. So if it is lying only in yz plane, it is going to have only y and z components. Understood? So if it is neither along our reference axis, then it is going to have its components along those reference axis. So this is the important note that you have to make. Okay, okay. So write down a note here. Write down a note. Write down a note. So if a vector is neither along our reference axis, then that vector is going to have its components along along those reference axis, along those reference axis. Okay, so this is the note you have to make. See, I am giving all the important points, I am giving as a note. So whatever I am giving as a note, those points are very, very important, right? Okay, okay. So now see here. Okay, so I am moving on to next page, right? Okay, so see here. So we have considered here horizontal axis, and here vertical axis, and here we have considered C bar, right? And this angle is theta. So the component of C bar along horizontal axis is nothing but C cos theta, right? It is pointing along AH cap direction, and its component along vertical axis is nothing but C sin theta. It is pointing along AV cap direction. Okay, so this is C cos theta we have represented with A, and this is C sin theta we have represented with B, and we have called this as B bar, and we have called this as A bar. Okay, so up till this point there should not be any doubts, right? Okay, so now here we try to develop a mathematical model how to determine the component of one vector along the other. Okay, now let us consider this vector C bar and this horizontal axis. Okay, now if you want to determine the component of C bar along horizontal axis here, okay, so mathematically how you can determine, mathematically, not graphically, mathematically how you can determine. See here, so take C bar, right, take C bar. You want to determine the component of C bar along which axis? Along horizontal axis. So C bar dot, okay, along horizontal axis, what is the unit vector? Unit vector is nothing but AH cap. So this will give you what? This will give you what is C bar dot AH cap here? That is magnitude of C bar into magnitude of AH cap into what? Into cos theta, cos of angle between these two. So that is cos theta. So which is equivalent to what? You are getting C cos theta, right? So whenever you are doing C bar dot AH cap, you are getting what? You are getting C cos theta. You are getting C cos theta, and this C cos theta is the component of C bar along what? Along horizontal direction. Understood? So this represents the scalar component. Yes or no? See, the resultant of dot product is nothing but a scalar quantity. So we call this as a scalar component of C bar along what? Along horizontal axis, along horizontal axis, along horizontal axis, right? Okay, okay. So similarly, if you want the scalar component of C bar along vertical axis, what you have to do? So take C bar and do the dot product with the unit vector along the vertical axis. What is the unit vector along the vertical axis? Is nothing but what? Is nothing but AV cap. So what you are going to get if you do this? What you are going to get? C. Okay, so magnitude of C bar into magnitude of AV cap into cos of angle between C bar and AV cap. So AV cap is pointing along vertical direction. So what is the angle between C bar and AV cap? Is nothing but this one. So this angle is nothing but 90 minus theta. So cos of 90 minus theta. So what you are going to get? You are going to get C into 1 into cos of 90 minus theta is nothing but what? Is nothing but sin theta. Understood? So therefore the component of C bar along vertical axis is nothing but what? Is nothing but C sin theta. Right? Okay, so this is called as a scalar component here. This is called as a scalar component of C bar along what? Along vertical axis, along vertical axis. So here it's not plural, it is vertical axis, right? Okay, okay. So now see here. Okay, So this is how you have to find out the component of one vector along the other, right? Now similarly, if suppose I have given two vectors here, let us say I have given two vectors a bar, okay, or I have given two vectors p bar and q bar. And if I ask you to determine the component, the scalar component of p bar, along q bar. If I ask you to determine what is the scalar component of p bar along q bar, then how we can determine that? Tell me, how we can determine that? Scalar component of p bar along q bar. What you have to do? So take p bar, okay, do the dot product with along which direction you want? Along q bar. So that means write the unit vector along q, right? So p bar dot aq cap is going to give you the scalar component of p bar along q bar, right? Okay, okay. So this is how you have to determine the scalar component of one vector along the other. Fine, right? Okay. So now, sir, okay, fine. You have explained how to determine the scalar component. So can you explain how to determine the vector component? See, we can easily determine the vector component also. How we can determine here? See here, this is c cos theta here. This is c cos theta is the scalar component of c bar along what? Along horizontal direction. Along which direction? Horizontal direction. Understood? Okay. So this is c cos theta is along which direction? It is along horizontal direction. Understood? See, I have already told whenever you want to represent the direction, you have to represent the direction with what? With unit vector. So here c cos theta is the magnitude of the vector. Yes or no? Or I can simply say this is the scalar component of c bar along horizontal direction. And this c cos theta is pointing along which direction here? It is pointing along horizontal direction. Understood? So that means if you just multiply this, so here I am writing, so c bar dot ah cap will give you the scalar component of c bar along which direction? Along horizontal direction. So you have to represent the direction also. Yes or no? If you want the vector component, you have to represent the direction also. So it is pointing in which direction? It is pointing in horizontal direction. So just multiply with what? Just multiply with unit vector along horizontal direction. So this is going to give you what? This is going to give you the vector component here. This is going to give you vector component of c bar along what? Along h bar. Or I can say horizontal axis. Understood? So what you are going to get? So this is equivalent to what you are going to get? You are going to get c into cos theta ah cap. So this is going to give you the vector component of c bar along horizontal direction. Understood? So similarly, if you want to determine the vector component of c bar along vertical direction, what you have to do? C bar dot what? Dot av cap. So this is going to give you the scalar component, and this component is present along what? Along vertical direction or along vertical axis. So just multiply this with av cap. So you are going to get the magnitude as well as what? As well as direction, and hence it is called as a vector component here. This is called as vector component of c bar along what? Along v bar or along vertical axis. So what we got? C into sin theta av cap, right? Okay. So we will take one simple problem here. We will take one simple problem or one simple example so that it is going to be crystal clear. So let us take a bar is equivalent to 2ax cap plus 3ay cap, and b bar is equivalent to ax cap plus ay cap, right? So let us consider a bar equal to 2ax cap plus 3ay cap and b bar equal to ax cap plus ay cap, right? Okay. So now if I ask you to determine the vector component, of a bar along what? Along b bar, then how to determine that here? So they are asking to determine the vector component of A bar along what? Along B bar, right? So what you have to do? So A bar dot what? Dot unit vector along B bar. So that is AB cap. So this is going to give you the scalar component of A bar along B bar. Okay, and this component is pointing along what? Along B bar direction. So just multiply this with AB cap. Just multiply this with AB cap. So this is going to give you the vector component here. Vector component of A bar along B bar. Right? Okay. So if you do this, what you are going to get? Tell me. So A bar is nothing but 2AX cap plus what? Plus 3AY cap. Right? So this is A bar dot AB cap, that is the unit vector along B bar. So what is the unit vector along B bar here? I have already told how to determine the unit vector. How to determine unit vector? So take the vector and divide it by its magnitude. Okay, so what you are going to get? You are going to get AX cap plus what? Plus AY cap divided by what? Divided by root 2. Okay, so this is A bar dot AB cap. So this is going to give you the scalar component. But what they are asking here, they are asking us to determine the vector component. So just multiply this with AB cap. So that is AX cap plus AY cap divided by what? Divided by root 2. Yes or no? Okay. So I have written the vector divided by its magnitude, that is square root of 1 square plus 1 square, that is root 2. Okay. Okay. So this is AB cap and this is A bar and this is AB cap. Okay. Okay. So I hope it is crystal clear. Now I think you can easily do this one. So what you are going to get? Tell me. So 2AX cap dot AX cap by root 2, you are going to get 2 by root 2. Next AX cap, 2AX cap dot AY cap by root 2. So AX cap dot AY cap will become 0. Next AY cap, 3AY cap dot AX cap by root 2 will become 0. Next 3AY cap dot AY cap by root 2, what you are going to get? You are going to get plus 3 by root 2, plus 3 by root 2. So this multiplied by AX cap plus what? Plus AY cap divided by root 2. So finally you are going to get what? You are going to get 5 by 2. Yes or no? 5 by 2 into AX cap plus AY cap. Okay. So the same thing I can write it as what? I can write it as a 5 root 2 or okay. So the same thing I can write it as a 5 by root 2, 5 by root 2 into AX cap plus AY cap divided by what? Divided by root 2. Right? Okay. Okay. So here 5 by root 2 is the magnitude here. 5 by root 2 is the magnitude and AX cap plus AY cap by root 2 is the unit vector. Yes or no? This is unit vector or not? AX cap plus AY cap by root 2. What is its magnitude? Its magnitude is equal to 1. See, always remember the magnitude of unit vector must be equivalent to what? Must be equivalent to 1. Right? Okay. Okay. So this is the magnitude of the resultant vector. This is the magnitude of the resultant vector and this represents the direction. Okay. So direction is always given by the unit vector. So this is the unit vector. Right? Okay. Okay. So this is the vector component of A bar along B bar. So this is how you have to determine. This is how you have to determine the component of one vector along the other. Okay. Okay. So I hope it is crystal clear. Right? Okay. So now we are familiar. We become familiar how to determine the component of one vector along the other. So next we will go for a vector multiplication here. Next we will go for vector multiplication. Vector multiplication. Okay. Okay. Vector multiplication. So here how many types of multiplications we are having here? So see here, first if I take a vector A bar and if I multiply with a scalar some k, right? This is one type of multiplication. So whenever I multiply a vector with a scalar, the direction of this vector is not going to change, but the magnitude of this vector will be scaled by k times. Yes or no? Okay. So the resultant here is nothing but what? The resultant here is nothing but a vector quantity. This is one type of multiplication. So this is multiplication of a vector by a scalar. So if you multiply a vector by a scalar, the resultant is nothing but a vector quantity. So whenever you are multiplying a vector by a scalar, the direction of this vector is not going to change, but its magnitude is going to be scaled by k times. Understood? And the resultant of this multiplication is nothing but what? Is nothing but a vector quantity. Next we are having a multiplication between two vectors here. Next type of multiplication, you are having multiplication between what? Between two vectors. So whenever you are multiplying two vectors, we are having two types of multiplications here. So one is dot product, and another one is called as what? Is called as cross product. Another one is called as cross product. Okay. So now we will see this dot product and cross product in detail, right? Okay. So I hope you have understood this one here. You have understood this type of multiplication. It is very simple. Now here this dot product, the resultant of this dot product, we know that it is a scalar quantity, and the resultant of cross product, we know that it is what? It is a vector quantity, right? Okay. So next we will see dot product here. Next we will see dot product, right? Next we will see dot product. Now see here, let us say I am having here a bar, and here another vector, let us say this is b bar, and let us say this angle between this a bar and b bar is theta, right? So we know that mathematically this a bar dot b bar is equivalent to what? Magnitude of a bar multiplied by magnitude of b bar multiplied by cos of angle between a bar and b bar. Okay, so this theta is nothing but what? This theta is nothing but the least possible angle between a bar and b bar. I have already told, whenever you are measuring the angle between the two vectors, you have to join the two vectors tail to tail, and you have to consider the least possible angle as the angle between the two vectors. I have already told this point. Yes or no? Okay. Yeah. So here theta is the angle between a bar and b bar. Okay, so a bar dot b bar is equivalent to magnitude of a bar into magnitude of b bar into cos theta. So this resultant is nothing but what? Is nothing but a scalar quantity, right? So now you can write this as what? So I can simply write this magnitude as a, this magnitude as b, so multiplied by cos theta. So here I can write it as a into b cos theta, or the same thing I can write it as a cos theta. A cos theta into what? Into b, right? Now if you observe here, what is this a cos theta here? What is this a cos theta? So see here, this is a bar. Now if you drop a normal from the head of a bar onto what? Onto b bar, So the distance from here to here, is nothing but what? Is nothing but a cos theta. So that means here a cos theta is the component of a bar along what? Along b bar. So in dot product, what we are doing here? We are multiplying the component of a bar along b bar with what? With magnitude of b bar. Understood? Or I can say in this manner, if you consider this one here, I can write the same expression in this manner also, that is a into b cos theta. So here what is this b cos theta here? So here I am extending this a bar here. So I am extending this a bar like this. Okay. So I am extending this A bar like this, right? Okay. Now just drop your normal. Now just drop your normal from the head of B bar onto what? Onto A bar. Just drop a normal from the head of B bar onto what? Onto A bar. Okay, so this angle is nothing but what? Is nothing but 90 degrees. So from this right angle triangle, what is the distance from here to here? The distance from here to here is nothing but what? Is nothing but B cos theta. Yes or no? The distance from here to here is nothing but B cos theta. So this B cos theta multiplied by A is nothing but what? Is nothing but the dot product between A bar and B bar. Understood? Okay. Okay. So here what you are doing, you are multiplying the component of B bar, along A bar with what? With magnitude of A bar. Now if you observe here, this B cos theta is pointing along A bar and this A is also along A bar only. So that means you are multiplying the two quantities, that are pointing in the same direction. And here if you observe here, A cos theta is the component of A bar along which direction? Along B bar. Yes or no? And here B is the magnitude of B bar and this B is also pointing along what? Pointing along B bar only. So here A cos theta and B both are pointing in the same direction. So you are multiplying the two quantities that are pointing in the same direction. Understood? Okay. So that is the physical interpretation of this dot product here. Right. Now another observation we can make here is so if theta goes on decreases, if A bar moves towards B bar here, okay, so then what will happen? The component of A bar along B bar is going to increase. Yes or no? So as A bar moves towards B bar, this theta value is going to decrease. Yes or no? This theta value is going to decrease. So as theta value going to decrease, this cos theta value is going to increase. As cos theta value increases, A cos theta value is also going to increase. So which means the component of A bar along B bar is going to increase as theta value decreases. Yes or no? Okay. Now similarly, if I move this A bar, away from what? Away from B bar, then what will happen? This theta value is going to increase. As theta value goes on increases, the component of A bar along B bar is also going to decrease. Yes or no? So let us consider this is B bar, right? So here let us say this is A bar. Now this is the component of A bar along B bar. Now if I move A bar further like this, let us say this is A bar. Now what is the component of A bar along B bar here? Now the component of A bar along B bar is only this distance. Okay, so as this A bar moves away from B bar, what will happen? This component of A bar along B bar is going to decrease and hence this dot product value is going to decrease. Understood? And once A bar becomes perpendicular to B bar here, so here theta is equivalent to what? Is equivalent to 90 degrees. So in this case, what happens to the dot product here? What is A bar dot B bar in this case? Tell me. Now here, if you try to drop the normal, okay, from the head of A bar onto what? Onto B bar, what you are going to get? There will be no component of A bar along B bar. So it is 0. Isn't it? Okay, so that means there exists no component of A bar along B bar, and hence in this case A bar dot B bar will become equal to what? Will become equal to 0. So what you are going to get here? This is A into B into cos 90 degrees. Cos 90 is 0. Right? Okay, so the dot product value will become equal to 0 when theta equal to 90 degrees. And another case, if suppose B bar is present like this and A bar is also present along what? Along B bar. Now in this case, theta is equal to what? Theta is equal to 0 degrees. Understood? Now here the total A bar is lying along what? Is lying along B bar. Understood? So in this case, what is A bar dot B bar here? A bar dot B bar is equivalent to what? AB into cos 0 degrees, which is equivalent to what? AB. So this is the maximum value of the dot product. Yes or no? So here in this case dot product will be what? Will be minimum, which is equivalent to 0. And in this case the dot product will be maximum, which is equivalent to what? Which is equivalent to 1. Okay, so whenever in this case theta is equal to what? Theta is equal to 0 degrees, and in this case theta is equal to what? Theta is equal to 90 degrees, right? So what is the conclusion we can make? The dot product will be minimum. The dot product will be minimum whenever theta is 90 degrees. Whenever theta is 90 degrees, there exists no component of one vector along the other, and hence the dot product will become 0, isn't it? Okay, so whenever theta is equivalent to 0 degrees, in that case both the vectors are going to lie in the same direction. So the total A bar will lie along B bar. So in this case the dot product value will be maximum. So in this case theta is equal to 0 degrees. Okay, so dot product will be maximum when both the vectors are lying in the same direction, and in this case theta value is equal to 0 degrees, right? And similarly the dot product will be minimum when theta equal to what? When theta equal to 90 degrees. Okay, so here you can say theta equal to 180 degrees also. When theta equal to 180 degrees, what is the dot product you are going to get? The magnitude here, if you consider the magnitude of dot product, still you are going to get what? You are going to get 1. Yes or no? So when theta equal to 180 degrees, what is the dot product? So A bar dot B bar, I am considering only magnitude, which is equivalent to what? A into B into what? A into B into cos 180 degrees. Its magnitude will be equivalent to what? Magnitude of A into B into -1, which is equivalent to what? A into B, right? So whenever theta equal to 0 degrees or 180 degrees, the dot product magnitude will be maximum. But whenever theta equal to 90 degrees here, there exists no component of A bar along B bar. So in this case the dot product will become what? Will become 0, right? Okay. So here you can make a note. Okay, so dot product will be maximum when theta equal to what? When theta equal to 0 degrees. And here I am considering A bar is not equal to 0, or you can simply write the magnitude of A bar is not equal to, or you can simply write A not equal to 0 and B not equal to 0, right? And the dot product will be minimum when theta equal to what? When theta equal to 90 degrees. So here also I am considering A not equal to 0 and B not equal to 0, right? Okay. Yeah. Right. Okay. So we will see one physical interpretation of this dot product. See, if suppose I am having a trolley here, let us say this is the trolley, right? So this is the surface, and a person is pulling this trolley in this direction. So that means he is applying the force in this direction. So whenever he is pulling the trolley by applying the force in this direction, so this trolley is going to move along what? Is going to move along the surface. It is going to move along the surface. Understood? So the displacement will be along the surface. So that means this is the displacement S bar and this is the force F bar, right? This is the displacement S bar and this is the force F bar. Now let us say the theta or the angle between this F bar and S bar is theta, right? Now in this case, what is the work done here? What is the work done in order to move the trolley here? So we know that the work done is equivalent to what? Is equivalent to force dot what? Force dot displacement. So if you do force dot displacement, what you are going to get? Here you are getting magnitude of force is F, magnitude of S bar, that is displacement is S, multiplied by what? Multiplied by cos theta. So Fs cos theta. Understood? Now here you can write this as what? You can write this as F cos theta into what? F cos theta into S. F cos theta into S. So what is this F cos theta here? F cos theta is nothing but the component of F bar along S bar. So if you just drop your normal from the head of F bar onto what? Onto S bar, the distance from here to here, the distance from here to here is nothing but what? Is nothing but F cos theta. Is nothing but F cos theta. Understood? So this is one physical example or physical application of what? Of dot product. So the work done is equivalent to what? Is equivalent to force dot displacement. Right? Okay. Okay. So one more thing here. I will take another example here. See here. Now if suppose a person is carrying a luggage. Okay. So a person is carrying a luggage over his head. So he has kept the luggage over his head. Understood? Like this, right? So and he is walking along the surface. So that means the displacement is in this direction. So he is walking along this surface here, right? Okay. So he is carrying the luggage. So he is keeping the luggage on his head and he is walking along the surface, So the displacement is in this direction. Understood? Okay. So this luggage here, is pulled by what? This luggage is pulled by gravitational field force in downward direction. This luggage is pulled by gravitational field force in downward direction. So against this pulling force, he has to apply the force in upward direction. Yes or no? So this person has to apply the force. In upward direction. So the force applied by this person, I am calling it as F external. Right? Okay. Okay. So against this gravitational pull, this person has to apply the force in upward direction like this. He has to apply the force in upward direction like this. Right? Okay. Now what is the work done by this external agent here? What is the work done? What is the work done by the external agent? Tell me. What is the work done by the external agent? What is the work done by the external agent? Okay. So external agent means this person here. What is the work done by this person in moving this, in carrying this luggage from one point to another point? So this is the displacement he has moved. Right. So what is the work done by this external agent here? The work done by this external agent is equivalent to what? Is equivalent to the force applied by the external agent dot what? Dot displacement. So that is equivalent to F external dot what? Dot displacement. Now here F external is in upward direction. Yes or no? And the displacement is in horizontal direction like this. So what is the angle between these two here? The angle between these two is theta equal to 90 degrees. Now in this case, what is the work done by the external agent in carrying this luggage from this point to this point? Tell me. So here what you are going to get? The magnitude of F external multiplied by the magnitude of S bar multiplied by cos of what? What is the angle between F external and displacement? Is nothing but cos 90, which is equivalent to what? Which is equivalent to 0. So here he is applying the force. The force is not equal to 0. Yes or no? And he is moving a displacement. Displacement is also not equal to 0. So both are present. But the angle between this force and displacement is 90 degrees. So in this case, what is the work done by the external agent? The work done by the external agent is becoming equal to what? Is becoming equal to 0. Isn't it? Okay. Okay. So the work done by the external agent here is equivalent to what? Is equivalent to 0. Right? Okay. Okay. So that means here what is the component of F bar? What is the component of F bar along S bar here? Is there any component of F bar along S bar? No. The component of force along the displacement direction is equal to 0 in this case. Yes or no? So the component of F bar along S bar is equal to what? Is equal to 0. There exists no component of force along the displacement direction. So in this case, the work done will be equivalent to what? The work done will be equivalent to 0. Understood? Whereas here in this example, there exists a component of force along the displacement direction. So here the work done is not equal to what? Work done is not equal to 0. So from this what we can conclude? Tell me. So for the work done not equal to 0 means there must exist a component of force along the displacement direction. So the work is said to be done if and only if there exists a component of force along the displacement direction. So this is the note you have to make. Okay, so write down your note here. Work is said to be done. Work is said to be done if and only if there exists any component of force, if and only if there exists any component of force along what? Along displacement direction. Along displacement direction, right? Okay, so this is the observation we can make, right? So this is one physical application of our dot product. Understood? Okay, so work is said to be done if and only if there exists any component of force along the displacement direction, right? Okay, so this is all about dot product here. This is all about dot product. Okay. So with this lecture, I am winding up this session here. So in the next lecture, I am going to start. I am going to explain the cross product and its physical interpretation, and we will see some examples for cross product. So once we complete this, if possible, in the next lecture itself, I am going to start coordinate systems. Right? Okay. So as far as this lecture is concerned, I am winding up the session. I am ending up the session now, right? Okay. So we will meet in the next lecture with cross product, right? Okay. So I hope all the concepts that we have studied in this lecture are crystal clear. Okay. So okay then, thank you for watching. So take care. Bye bye. We will meet in the next lecture.